Hello. So one of the neat things about Habitat is its support for lifecycle hooks, specifically um, health check hooks, which are a built-in mechanism for monitoring the health of your application. Every application defines healthiness specifically in a little differently, but most of us at least want to know how an application is performing at any given time. And the health check hook is a great way to do that. You'll find it documented here under hooks and then health check. Monitoring application health usually involves a few steps. First, you write some code into the application itself to, so for like a web app, for example, this might be an API endpoint that returns some payload indicating uptime or latency or something. Second, something needs to be written to call that endpoint on some interval, which is what the health check hook is made for. And then finally, something has to be done with that data to track its changes over time and make it actionable. And one way to do that is to funnel it off to a third-party service like Splunk. So I'm going to demonstrate a package that I've been working on that takes Habitat health check data and sends it to Splunk using a feature that they call their HTTP event collector. So I have a few packages here on a virtual machine. One is a really simple Node.js application that just defines a health check endpoint, basically. Another is an Nginx web server sitting in front of it, and then a proof of concept service that I've written here called Hello Splunk, whose job is to listen for locally running services health check data and forward it off to Splunk. So my Node app declares an optional binding on the Splunk reporter, and then uses that binding to post its health check data on some default interval. So looking briefly at the code for the health check, you can see I'm just calling the node services health endpoint, and then taking its JSON payload and forwarding that on to the locally running Splunk service, which then passes it on to Splunk. Now we'll probably do some work to make these a little bit, to package these up a little more nicely so that you can consume them easily, not have to write all of them yourself. But this is what I've got now, and so I will show you how it works. So I'll switch over to Splunk now and show you my dashboard. This is just updating on an interval. And now back to my virtual machine, and I can start my services. And see down here the same, so they're all running. You see one of them is flapping. The Splunk service is flapping because it doesn't have its configuration that it needs. So I will just apply that here. And now the Splunk service is running, and everybody's happy. And if I switch over for a moment, I should see in Splunk, ideally anyway, some events start to spill in here. Let's see. May take a little bit. There we go. So the first one fell in. Here's my service. It is the Hello Node package. And yeah, that's it. So these will pile up, and you can write all sorts of fancy things inside of Splunk to make your data more visible and actionable as you like. So that's the demo. I hope to be able to release this into your hands soon. So keep an eye on the Habitat blog and the forums for news to come. Thanks for watching.
Hey everyone, I am going to be demoing the Habitat Updater service that runs inside your Kubernetes cluster. The reason that this is important is because you don't want the Habitat supervisor automatically updating itself in your immutable Kubernetes environment. What you want is something to check for updates on Builder, and when it notices one, it's going to orchestrate a change through the Kubernetes API to make that update happen. So let's get started. So I've taken the liberty of deploying this already, and I'll show you that. So you can see that my updater is deployed via just the Habitat operator, using the Habitat operator YAML. And so what we can do is we can watch the logs for this, and you can see it's polling for updates. And what's really neat about this is the Habitat updater is actually packaged as a Habitat package. So it's going to actually watch for updates on itself, and that's how I'm going to demo this today. All right, so what we want to do is we want to show this end to end. So let's make a change to have the habitat updater, instead of polling every 1 minute, we're going to have it poll every 15 seconds. Cool. So what we need to do to make this change go is make a commit habitat updater. So we're just going to add that. All right, so now we're just going to push that change up. All right, so now it's gone. And if we're lucky, we'll see a build job get automatically triggered. But we've also been seeing some increased build capacity today. So I'm just going to manually trigger this job. We can watch it build. So after this gets done building, what we'll see is it'll go into the unstable channel. It's also worth noting that right now the habitat updater is only watching for changes to the stable channel. But in a future iteration, once we get channel support added to the habitat operator, we'll be able to watch for whichever specific channel your supervisor is pinned to. All right, so now our package has been published. And so what we want to do is come back over here to look at the versions, and we're just going to promote this latest version to stable. Go ahead and promote it. Right, so that's done. So now we should see in 1 minute's time, the habitat updater service will update. All right, there it was. So you can see that 2 services are loaded. The latest version of Redis was installed, but we detected a newer version of the habitat updater. Our pod detected that signal from the orchestrator and terminated itself. And so now, if you look, it will have terminated itself, and the new updater pod has been available for 20 seconds. And so if we turn the logs back on for that, we'll see now we are up and running again, and we're polling for more updates. Thanks for watching.
Hello, my name is Indradhanush Gupta, and I'm a software engineer at Kinfo. Today I will be demonstrating the Habitat Service Broker. The first prerequisite of a Habitat Service Broker is a functioning Kubernetes cluster with RBAC enabled. We will be using Minikube to demonstrate this locally. So let's start our cluster. Now that our cluster is up and running, we will now install the next prerequisite, the habitat operator. Now that the habitat operator has been installed, we will install the service catalog, which is a wrapper around the Open Service Broker API. This can be installed using Helm. The service catalog is installed under a namespace called catalog. So let's verify if the service catalog has been installed. Now that our final prerequisite has been installed, we can now move on to deploying the Habitat Service Broker. But before that, let me tell you about the svcat command line tool, which can be used to interact with the Open Service Broker elements present in the Kubernetes cluster. At the moment, there are no brokers installed. The broker is installed in a namespace called the Habitat Broker. We can see that the Habitat Broker is ready. We can also verify using the svcat command. We are waiting for the broker to be in a ready state, after which we can start using it. Now that the broker is ready, we will take a look at what are the available applications that we can install using the broker. For our demonstration, we will be using the Redis Habitat app. We will create a service instance of the Redis app. To do this, we will apply the following manifest. Now we can take a look at the instance using the svcat command. This will also start a new Kubernetes pod. Once the Redis pod has been created, we should be able to use it. Although the Redis pod is in running state now, we cannot yet use it without creating a binding. The binding will create a Kubernetes secret object which configures Redis to be used with a password. Currently, there are no bindings installed. To install a binding, we will apply the following manifest. The binding is now ready for use. But before we can log into the Redis server, we need to know the authentication password. This information is stored in the secret that was created as a result of creating the binding. The secret that we need is called Habitat OSB Redis and a random string. So let's take a deeper look into what's inside this string, inside the secret. As you can see, the data part of the secret contains a key value pair. This is used by Habitat to configure the pod. The value of the user.terminal key is a base64 encoded string that is directly mapped onto the Redis configuration. We will now decode this and see what is the content of that. Now we know the password that is required to connect to the instance successfully. We will use this password with the Redis CLI which has been installed before the demonstration. But to connect successfully, outside the cluster, we need to expose the Redis instance as a service. We will apply the following manifest for that. As you can see, we can connect to port 30,001 on the Kubernetes cluster to connect with the Redis pod. We need to get the IP address of our cluster. We will use this to connect. Oops, we haven't applied the service manifest yet. So let's do that. We should be able to connect now. We will now use the password obtained from the secret to authenticate ourselves. Now that authentication is successful, we can use the Redis instance. We will now delete the pod. Since this instance is being managed by the operator will ensure that a new pod is placed in place of the deleted pod. We are using persistent volumes, so we expect our data from our previous session to be found even after deleting the pod. Let's verify that. As you can see, even after deleting the pod, the data has persisted. We will now remove the binding, which will prevent us from accessing the Redis instance from outside the cluster. As you can see, the binding has been removed, and so has the secret. So let's try connecting with the password that we used last time. As you can see, the connection has been denied. With that, we come to the end of this demo. Thank you for watching.
Hi everybody, I'm going to do a quick demo of Azure AD as one of the OAuth providers for our on-prem builder. What you're seeing on this main page is our README. We have now updated it with Azure AD as one of the supported authentication providers. And one other thing I want to show you real quick in this sample and configuration, we now have Azure AD as an auth provider here and some sample URLs for the for Azure AD here, login microsoftonline.com. Okay, so on this left-hand side of this window, I have already pre-configured on my local machine configuration for Azure. I'm going to hit login here. It's going to take me to Microsoft. I'm going to enter my email, hit next. That's going to take us next to Okta, and I'm going to sign in there. And don't save. And one more dialog, and we should be signed in a moment. And here we are. Okay, so now we're signed in. I already have an origin pre-created for Azure, so you can see, you're seeing that here. And that's basically it for the demo. We now have the ability to sign in with Azure. That's it. Thanks for watching, and see you next time.